We have done our theory that if whatever the direction of force, the welded joint always fail due to shear, and the value of the shear will occur at theta equal to 45. That is, the throat plane is inclined at an angle of 45 degree. We'll consider here a single transverse fillet weld. We have given here two plates here, and we want to do the welding in this area. And since we have a transverse fillet weld, so the direction of the force is perpendicular to the axis of the weld, and we are going to do the welding at this point. It's a fillet weld, so axis of the fillet weld is perpendicular to, hence it is called as a transverse fillet type of weld. It may be possible here that whatever the isosceles angle we are getting here, that is the ideal situation, but sometimes that is the leg length at the top weld will be higher value, and on the leg weld on the upper plate will be lower value, or we can have isosceles triangle. Suppose we have both the leg of same size, that is we have leg size equal to h and the leg size equal to h. In that case we can calculate the dimension t, and dimension t, that is the throat thickness, is same as equal to 0.707 times the leg size equal to h. And suppose you come across a situation in which we have a unequal length, like this leg length equal to h and this length equal to h prime, which is greater than h. Whenever you come across this situation, in that case you have to inscribe here the largest possible isosceles triangle. So largest possible isosceles triangle that we can inscribe is of height equal to h. So you have to draw here one isosceles triangle, and this height is same as equal to h. So this will become our fillet weld with a equal length, and again we have t is equal to, that is the throat thickness equal to 0.707 times h. So the size of the fillet weld is specified by the leg length. So that is the one issue that we have solved. Suppose we have given the equal and unequal length. Now we'll design here the single transverse fillet weld. In this weld, the planes are perpendicular to the force applied and would responsible for shearing as well as tensile stress development in the weld. But we know that only you have to consider the value of the shear stress for designing purpose. So the top view we have shown here, we have one plate, that is a bottom plate, and we have top plate. Here we have done the fillet weld. The length of the weld is equal to L, and we have fillet shown here. The symbol of this fillet we have to show by using an arrow. So we have to show the arrow. This one is the reference line, and we have fillet weld. Symbol is familiar to you. You have to show by triangle, and you have to specify the size of the leg equal to h. So this one is the standard symbol used in the case of fillet weld. Whether we have a case of single transverse, double transverse or parallel, the failure is always by shear. And for this failure, we have resisting area is same as the throat area, and we have throat area is given as the product of throat thickness, that equal to t multiplied by length of weld L. This time we have throat thickness is equal to 0.707 times the leg size. So we have 0.707 multiplied by leg size multiplied by L, that is the length of weld. So the shear stress we can calculate as tau is equal to the force F divided by area A, that is same as equal to the force F divided by 0.707 times h, that is the leg size multiplied by length of weld, and this value of tau should be less than equal to SYS. Procedure for calculation of SYS is known to us. SYS divided by tau is same as the factor of safety. Now this figure represents here the double transverse. We have fillet weld of length equal to L, that is shown here, and one fillet weld is done at the bottom whose leg size equal to h. So again I have to show this with a standard symbol. Then you have to draw the reference, and then you have to show the arrow pointing it. So this arrow pointing it will be representing as the fillet weld, and one fillet weld will be offset here. So you have to show here two fillet weld, one at top and one at bottom. We get a resistance across this area, which is throat thickness T multiplied by L, and the second area is again T multiplied by L. So in this case the total resisting area will be equal to 2 times the throat area. So this is the difference between the single transverse and the double transverse. In the case of double transverse, the area will become 2 times of the throat area. That will be 2 times of T multiplied by L is same as equal to 2 times of 0.707 multiplied by leg size H multiplied by length of weld is equal to L. 2 multiplied by 0.707 is 1.414 multiplied by H multiplied by L. So again we want to calculate here the shear stress. That the shear stress is force upon total resisting area, that will be equal to F divided by 1.414 multiplied by H leg size multiplied by length of weld L. In the case of parallel lap joint here, we have the weld shown on the top side as well as on bottom side of two different length L1, L2. A joint is called as the parallel lap joint if we have two plates lap over each other and the axis and the direction of force are parallel. In that case it will be called as parallel lap joint. Whether we have a parallel lap joint or transverse, single transverse or double transverse, failure is always by due to shear. Now we want to calculate here the total resisting area, that will be top side plus bottom side. Now we have total resisting area is represented by A T will be equal to the throat thickness T multiplied by length on the top plus the length at the bottom, that is L1 plus L2. Throat thickness T we can replace as 0.707 multiplied by the leg size H multiplied by L1 plus L2. And then we can calculate the shear stress using the same formula. So shear stress is same as force upon the total resisting area, that will be equal to F divided by 0.707 times the leg size multiplied by total weld length L1 plus L2. If the external force applied will be larger value as compared to the transverse and double parallel, then we can think of double parallel and the transverse joint. So this length L1 and this length L1 represent the length of the parallel fillet, and L2 represent here the length of the transverse fillet. Total force F will be divided into two parts, F1 and F2. F1 represent here the force for double parallel fillet and F2 is the force for transverse fillet. The throat area A is given as the throat thickness T multiplied by corresponding length L. In the case of parallel fillet, you have to take the length as L1 plus L1, that is 2 times of L1, and in the case of transverse we have length equal to L2. The throat thickness is same as equal to 0.707 multiplied by H multiplied by L. So the force for double parallel fillet, that is a failure, is again by shear. So every time you have to only consider failure by shear. F1 will be same as equal to the force for double parallel, which one is throat area, is 0.707 multiplied by leg size H. And since we have double parallel and both has equal length, that is L1 plus L1 multiplied by the shear stress tau. L1 plus L1 is 2 times of L1, 2 multiplied by 0.707 is same as equal to 1.414 multiplied by H multiplied by L1 multiplied by tau. Tau value remains same for both transverse and parallel unless and until mentioned. We have F2 value is equal to the force for transverse fillet is the throat area, which one is 0.707 multiplied by leg size H. This time you have to consider the length for transverse fillet, that equal to L2 multiplied by the shear stress tau. So in this fashion we can calculate the total force F, which is equal to F1 plus F2. Based on this we will take the some basic numericals which appear in the GATE examination. The type of the weld represented by the shaded region in the figure is a groove type, fillet type, spot type, plug type. So this one is a symbol of a triangle. It means that this one is a fillet type. Choice B is correct choice. A 60 mm long, 6 mm thick fillet weld carries a steady load of 15 kN along the weld. The shear strength of the weld material is equal to 200 megapascal. The factor of safety we have to find out. So we have given here the length of weld equal to 60 mm, thickness of the fillet weld, that is the leg size, is given as 6 mm, and we are applying a steady load of 15 kilonewton, and the shear strength of the weld material is given as 200. Now this time it is not mentioned whether we have a transverse or a parallel fillet, but whatever the case it may be, the failure is always due to the shear. So we'll consider here a transverse loading. We know that for transverse as well as parallel fillet weld, the failure is purely by shear. Anyone you can consider. So this time I will consider the transverse. The length of weld is given as 60 mm. So we have L is equal to 60 mm. We have leg size is given as 6 mm. So we have value of H is equal to 6 mm. And a steady load of 15 kilonewton. So we have F is equal to 15 kilonewton. The shear strength of the weld material is SYS is equal to 200 megapascal. We have throat area is A is same as equal to is T multiplied by L. We know T is equal to 0.707 multiplied by H multiplied by L. So the given force is F is given as tau multiplied by area A. So we have F is equal to tau and area is given as 0.707 multiplied by H multiplied by L. F we have to substitute as 15,000 Newton. So we have 15,000 Newton. Tau we have to find out into 0.707. We have H, that is the leg size, equal to 6 mm, and we have length of weld equal to 60. Solve this, you will get the value of tau. So shear stress developed for the given loading is 58.935. 58.935 is megapascal. And SYS is known as 200. So we have factor of safety FOS is equal to SYS divided by tau. We have SYS is equal to 200 and tau is equal to 58.935. So in this case we get a factor of safety close to 3.4. A fillet welded joint is subjected to transverse loading F as shown in figure. Both the legs of the fillet are of 10 mm size. Leg size means H is given 10 mm. Weld length is given, that equal to 30 mm. So this one is weld length equal to L. The allowable shear stress is 94, and considering the minimum throat area of the weld, the maximum allowable transverse load F you have to find out. So this one is figure representing a double transverse fillet. We have leg size equal to H and the weld length equal to L. We know that for transverse and parallel fillet weld, failure is by shear only. So this time we have given the leg size H equal to 10 mm, weld length L is equal to 30 mm. The shear stress tau is equal to 94 megapascal, and we have double transverse. F we have to find out. So F is same as equal to tau multiplied by total throat area. So we have tau. Here we have 2 fillet welds, so we will multiply by 2 multiplied by T multiplied by L. We have tau 2 times. Throat is same as equal to 0.707 of leg size H multiplied by L. F we want to calculate. Shear stress tau is equal to 94. 2 is for double transverse into 0.707 into leg size H, which is equal to 10, multiplied by length of the weld equal to 30. So maximum allowable transverse load is come out to be 39.9 into 10 to the power 3 Newton, that is 39.9 kilonewton. This answer is Newton. You have to divide by 1000. A plate of 15 cm wide, 3 cm thickness is to be welded by means of double transverse fillet. The plate are subjected to static load of 15 kN. What should be the length in cm of the weld if the permissible shear stress is 3.5 megapascal and the permissible tensile stress is 4.5 megapascal? We have given the case of double transverse. So this figure represents a case of double transverse. We have given here the plate size is equal to 15 cm wide. So we have width of the plate is equal to 15 cm. And the thickness is same as equal to the leg size equal to 3 cm. By means of double transverse, the plates are subjected to the static load of 15 kilonewton. So we have F is equal to 15 kilonewton. And we are given the permissible shear stress tau is equal to 3.5 and tensile is 4.5. We want to calculate here the length of the weld. So this length of weld we want to calculate. We know that whether we have a transverse or parallel fillet weld, failure is always by shear. So out of the shear and the tensile, you have to consider the shear stress only. That is value of tau is equal to 3.5 megapascal. The length of the weld we have to find out. In this case, we have force F is equal to tau multiplied by total area resisting the shear, that is A total. So we have F is equal to tau. We have double transverse, so we have multiplied by 2 multiplied by T multiplied by length of weld equal to L. So we have F is equal to tau 2 times. Throat is same as equal to 0.707. So we have 0.707 multiplied by leg size H multiplied by L. This time the value of the force is given as 15 kilonewton. You have to use that value in Newton is 15,000. Tau you have to use as 3.5 multiplied by 2 for double multiplied by 0.707. We have leg size is given as 3 cm, that equal to 30 mm. From this we can calculate the length of weld. So if you solve it, you will get the length of weld L is equal to 101 mm. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.